Bye.
You just ask the tour guide how high it is.
The tour guide's uneducated.
The tour guide.
Why don't you just...
It's the tour guide's first day.
Look at the plaque.
So, back in the day, for real, like, back, I can't even remember how many years ago it's probably been since the, well, actually, can you go up the statue anymore? I know you can't go all the way up.
I went up, like, I went all the way up not too long ago. I was
Okay,
like,
how long is not too long for
like
you?
a year?
Like, up into the head?
Yeah.
Really? Okay, so I know they had been doing some construction, and for a while they had it closed out. You couldn't even go in the statue for a while. And I think some of that was maybe also due to like security concerns and whatnot. But so let's say we're at the Statue of Liberty, right? And Lindy is worried about taking the tour. I'll come to you in a second because she gets nosebleeds if I think it's a she. Yeah. When she climbs above over 300 feet.
That's strangely
Now,
precise.
that is strangely precise. They have, I don't know. Well, so like if you worked in a tall building or something like that, you'd know, like there's a lot of buildings downtown that go over 300 feet. Traditionally, you could say each floor of a building is 10 or 12 feet thick. Because the tallness of the floor and then the depth between them, right? Like ceiling, floor, all that stuff. Even more than that in bigger, nicer buildings, whatever. So that's like 30-story building, right? Not even 30 stories. Like Rhodes Tower, a bunch of buildings downtown are taller than that. So, since she doesn't want to get a nosebleed, she takes some time outside of the statue and collects some measurements, right? Because all of us would do that. So she finds a spot directly under the torch and then measures 42 feet away and determines that the angle up to the torch is 82 degrees. Now, back like years ago, and they might have reopened it now, you could go up into the head and then you would go out and climb a ladder that goes on the back of the arm and go up on the torch.
They have reopened the crown. They have not reopened the torch.
Bless you.
Wait, question.
And it doesn't look like they're planning on opening it either.
Yeah, it's an exposed ladder. So I don't know how like they made it relatively safe. If I was on there, I'd want like my harness on and some carabiners and stuff. But like so when people climb up water towers and stuff, there's a ladder, but there's like a cage around them.
Yeah.
This was like an exposed ladder.
Yeah.
You fall.
Wait, you got
Probably.
Wait,
Or pretty darn
when
hurt.
was this?
I mean, for a long time, until they like wised up and said
And
this
if
is
you
too
got lucky
dangerous.
enough to hit the water, this is relative.
You will still
You
die.
die. You would definitely die.
There's no way you
But-
can make it out to the water. Here, I'll show you this. Because now we're curious. We had to do the same thing with the Tower of Pisa. We had to like look up pictures because they just got stuck.
Yeah, it says the staff still climbs the ladder. It's a 40-foot ladder
Nice. That sounds cool.
from the ground to the torch.
My dad's a drug dealer and he goes hired for his work.
So here, that's not a very good picture. You need high quality. That's the issue.
Cool. Like that picture?
Now you can't see the ladder, but you can see like where you would be standing up there, and it'd probably be a pretty epic photo opportunity.
You know the Statue of Liberty is actually green to promote nature and how we should treat the economy?
It is not.
That's
The topper goes out. Yeah, come on.
It has not always been
That is
green.
facts. Would you like a one-way express ticket to the joke?
Satya, it's not funny if it's just straight up not true.
It's
No
true
way
and it's scientific fact.
Whatever.
All right, this seems like a futile effort here. I mean, we can try to zoom on this picture, but it's low res.
Wait, what's
It
that
doesn't
red
work.
thing?
Like, when it
They
says-
like put a giant banner thing up there as to
Oh.
like look like a flame. I think occasionally they will. That's Photoshop. No, that's not even. That's just a thing. Just like made of plastic or something.
Look at
Yeah.
that delivery
So
ladder.
do research on your own if you want. But it's dangerous.
Oh.
So there's people up on top of there.
Yeah, you just moved and
All right. So now our objective. You figured it out already. Using this data, how tall or how high up would you be at the torch? So take a moment, talk with your group about what to set up. Now be careful, that last sentence there gives you a little bit of info you need to make sure that you're accurate.
A Liam is standing 60 feet from a telephone
Her
pole.
eyes are 5 feet above the ground.
We should model this.
Do you know the one angle 90?
Oh.
So this is a telephone pole.
So
Standing 60.
basically, if you do 10, 42 feet away.
No.
Multiply.
She's 5 feet off the ground. Her eyes are
So if I spot directly 42 feet
No one
away.
does.
42 feet from the
Yeah,
ground.
been talking
Up.
Or
Her eyes.
It's 42 feet.
Why did I
like
look
5
at
feet
you?
away.
I don't know if you're
Yeah.
trying
Yeah,
to
that's
start
it.
your homework, or if you're
Feet away.
really getting confused every day about what
So
problem.
what about 5 feet over the ground?
Okay, so this is my
Yeah.
tower. Exactly what tower is.
What?
Isn't it 42 feet up? Or no?
I thought it was sideways and 5
She
feet up.
is 42 feet away.
Why did she choose
Yeah.
42?
So,
Yeah.
just like we talked about Leaning Tower of Pisa, torch, right? The spot on the torch is like right there. And I then backed up 42 feet.
Who does this?
We were about to, outside.
Ooh.
Because we're
Her
nerds.
eyes are, so she says 5 feet tall.
No, I don't get it.
No, she's over 5 feet tall. Her eyes are 5 feet tall.
Your face doesn't like stop, right?
It's not 300.
She's probably like 5'2".
No, it's 300 times 5. Your eyes are 5 feet. No, the actual tower is 300 feet tall.
Yeah,
you
you
got
got 5 feet tall.
Got no way.
It's actually 5 feet and up.
I feel like I'm doing this.
That's what happens.
Should we?
Okay, let's
It's not
Calculate.
good. You need to take
Yeah, and multiply it. Multiply it by 42. And add 5.
So 42 tangent of
Oh.
82.
So that would be X minus
I have no idea why I have this.
We
Ah,
disagree.
Ooh.
No, no, two.
Oh,
We don't
wow.
Uh-oh.
we know that one angle is 82, so that means
I don't know how it would have been. Like maybe we had it in
Really?
class.
I
and
think
then-
It's funny because my first year I ran.
Yeah, I said my triangle like this: 42,
That's
X
not-
minus 5, 82, 16.
Okay,
She was
Oh yeah.
And that increased
Yeah.
That's what I said.
Just one.
Okay,
So,
so-
So like yeah,
times
it's
303.84.
It goes to 300.
Gosh, it's gonna get
No,
really
But I'll still take it.
I still like the small storage
I got
over
the
at
same thing he did.
McCord.
But since she's
I think
like
they get like the
5,
ladder out or something.
5
Unless you
something.
put them all in
Multiply by
there.
42
Like
and add
future
5.
walls. They're
Yeah,
probably
it's tangent of
old
82.
ones that are no good.
Wait,
It is
are
a
you
good
no?
idea.
She won't.
Santi, that's right.
No,
Don't
but
mess
the
up.
tower's only
Okay, make sure you're on degree. Make sure you're on degree.
I'm on degree.
Okay, we're not counting the door back. So it's just 582.
10 million. Then multiply by
Let's
42.
do 42 tan 82.
All right, so Mr. Smith and I were talking this morning, and I'm going to utilize the fact that he's still in here to reinforce how lucky you guys are compared to us.
Do this.
Now, it's harder to be a kid these days because of technology, I'll give you that. But Mr. Smith and I weren't taught math as well as you guys are, not because of your teachers, but because of how we've restructured math. So we were talking this morning about, did anyone ever explain to you what tangent actually did? No, unfortunately, Mr. Smith actually had the opportunity to skip a math class in high school, and he kind of skipped over trig in a way, which is not great because then he didn't understand things when it got up into the engineering classes. But can we explain to Mr. Smith, can somebody, not everybody talking over each other, explain how we could use the tangent of 82, our calculator, what it does, and then relate that to figure out the height of the tower if we are 42 feet away? Jacob?
We can use the tangent of 82 to find the slope of the hypotenuse, and then multiply that by the 42 to find the opposite.
So does this give you your answer as a ratio in the calculator or as a decimal?
Decimal.
And you can actually make it, if you just hit the FD button, it'll swap it between fraction and decimal. So if you want it as a decimal, and these ones have it, I'm used to the TI, the other ones. You want to go...
This will work on plastic, only works on math credit. That's right, so only works on math credit.
Okay, so if you switch your mode, then you can get your answer as a ratio. But what is it as a decimal? Sorry?
298.8.
Two, and what?
No, you have to add 5.
So,
that's the final
Mindy, you're ahead of me.
You have to
Okay,
add 5.
we're talking about what is the slope ratio. So sorry, what's the slope? What is tangent of 82?
1-1.
7.1. I love 0.12.
So it's 711.
Yes.
Or 7.12.
So if we try to make that into we could just as easily make that a fraction as doing that, right? Now this is approximate, but and this is where like literally my mind was blown a few years ago. So what this is telling us, Mr. Smith, because we were talking about this morning, like us math teachers kind of nerd out together. With an angle of 82 and a run of 1, you have to rise 7.11. That's what tangent is doing. So you get this now because you were struggling with that yesterday. So then, if my run is 42, we use what we know about equivalent ratios. We multiply by 42 in both places, and this you said is 298.
We gotta add 5.
But that's from her eyes. I can't draw eyeballs on here. But if that's from her eyes, we still need to add 5 more feet. Right? So up on that torch, you would be at 303. What?
According to your diagram, it took 20 per head.
298.84.
Yes. She's a very large head.
Yes, I know. Like as big as the statue.
Yeah.
Right?
Like, so her head is like this. It's like
It's perspective. We're closer to her than we are to, right? It's perspective.
What about her neck?
Things look bigger when they're closer.
Holding that up.
So, what could we tell Lindy?
Don't break the fishes.
Bring
Thomas?
some in a hurry.
Where would she be safe to go to? Levi?
To the head.
Yeah, you can go to the crown.
No, if she goes to the handle thing, she should bring a cup so you can transfer the blood.
No, if she
That's
goes-
not how it works, in case you're unaware. And this is why health classes are important.
She doesn't like go to
Did you know that in the Apollo mission, they just said bring a cup and then have other things drink them for the last.
You can drink your own urine like 7 times before it's toxic.
Wait, you can
But
drink your own?
how is that related to what we're doing right now?
You said drinking blood, drink your own blood. And
No, I didn't, but
I saw that.
So that would work. But drinking your own blood does not get blood back into your body. It just actually that's bad for you.
Oh, really?
There's a bunch of iron and stuff in it. Yeah.
Yeah,
It
but
does
I
not
know
put
that
it back into your bloodstream.
Yeah, but it's
I
not
did
From your blood.
Yeah.
That then you're going to put in your stomach and process through your intestines.
They're going like this.
Okay, next.
So-
Vampires are very-
Our blood going like this.
Okay, so we refocus.
Yes.
We have until 28,
I'm losing
25,
Go ahead,
26.
It says 25 on our schedule. We had
Well,
this fight
it
last
says 26 on my schedule.
We said this last
So-
time.
24.
I know what my answer would be to this, but I first have to give you some setup. A clinometer. Like, do you think I'm going to explain the what the heck? A clinometer is a tool that can be used to measure incline. Get it? That's not a job.
We just
The
want to
question
show
is,
what the
is not a job. So, we want to figure out a way to invent our own clinometer with the objects that we have in this classroom. So that we then... If you want to teach, you can teach. You just have to prep ahead of time. We then will be able to indirectly figure out the height of anything we want. Right? So, my task to you is in the next, less than that, like 3, 4, 5-ish minutes, you have access to anything in this room. I want your group or yourself, if you like think I'm smarter than them, I'm going to do my own thing. You need to make whatever you think would be an effective clinometer to measure the incline angle from horizontal, like the ground, up to an object that we cannot reach. Right? Top of a tree, top of a flagpole, top of the White House, top of Mount Everest, whatever you want to think of that we can't reach. Make a clinometer.
Do you have a big, meter stick or protractor? Do you have a big protractor?
What's the
Oh,
Look at
guys,
that.
I want you can find the angle.
I have this.
And then a
That'll
protractor
work
so we can measure the angle.
Guys,
So like use this to measure.
use this then we got ourselves a big protractor.
Everybody-
Wait, we can measure this.
Everybody-
We can measure this.
Well, I'm gonna demonstrate.
MacGyver.
Yeah.
I don't
How
say
they
it.
made it in letters.
You should have the right.
I already did this very.
Oh yeah, those are so good.
Yeah.
That's what I mean. I like the view because it's like you got PVC plates attached on top, but it's because that's like the fishing poles and more of the like long gear that you end up having. Just the stuff where it like makes sense. And then there's that ghost
Excuse me. This is our big protractor. We don't care.
I saw one yesterday that 79 inches.
Let's go. Come on, Chris. Work.
Chris, we need to work. Anyway, yes, we got it. Yeah. Oh, you need a ruler.
So you can measure distance out and then you have the
I smell something
Mr.
but
Hudson.
it smells like Axe or something.
So we can. All right. We've got our chronometer, compass, and then protractor. Mr. Hudson.
Would this be beneficial to you?
Yes. So we basically do this.
So the thing is,
What
we
is
don't
what?
have it.
We need a
I was about to say, what, are we gonna like? I was gonna be really dumb with this.
Are we gonna do this?
So it would work.
I would request.
But
So once you're ready,
These are weird tops.
accidentally put
Honestly,
somebody in the house.
these are
Once you're ready, grab a seat again.
Honestly, it's not my top six.
On your paper, we as a class need to decide, and I think yours are front back if I copy these right. Is it? So we need to decide 3 things that we're all going to measure like at different times. We will measure them, and then you have 3 just open opportunities. So one that I'm going to require is that we try to indirectly measure the flagpole. So for object 1, go ahead and write down flagpole, and go ahead and draw like a little picture of how we're going to deal with this. Or actually, you don't have to draw the picture yet. We can do it outside.
It's just a pod.
What would we like to be object 2?
A ruler.
No. An object outside that we have to
Phoenix.
find. The building?
Yeah.
Where? It changes heights.
Right.
We're gonna go up front.
Right in front of the name. Like,
Above
No, we
Phoenix,
should
like
do-
the height of Phoenix above it. So yeah.
Human.
To do Phoenix? No, because we could directly measure a human. We're doing things that we cannot directly measure. Phoenix. So object 2 is Phoenix above name, because our name is on the front of the building.
Oh.
So object 2 is going to be Phoenix above the name. What about object 3?
A tree. No, wait.
Which tree?
we need a tree.
The thickest tree.
There's a little
Yeah.
tree. I found it.
Yeah.
There's a little tree next to the fence. Next to the
Oh, we want big
wall.
trees. What if we do the tree right outside the pod?
Yeah.
The big, I think,
The one
it
dude
drops
right
the spiky balls.
What?
I have no idea. The spiky ball tree, whatever it is. So tree.
Like plus three. Let's do that.
Spiky tree.
What about a cloud?
A cloud.
Um,
How far away are
That
we
big
from
one
the
that
base?
looks like a dolphin. Sure, there's a cloud.
that one
All
that
right,
looks all
so-
pretty out.
Here's what's up. You have, and we're gonna go out there together. You have until 11:15, and maybe even just a little bit longer than that, to work as your groups. Now, don't all be measuring the same thing at the same time, and take something out there if you want something to write on, like a binder or a book or something like that. But I would encourage you, go 3 different places. So if you see somebody heading to the flagpole, head somewhere else. Once we come back in, we're going to compare measurements with each other, right?
Call flagpole. Yeah. Call 3.
Now, hopefully, I think every group has figured out you need a tape measure to figure out distance from the base.
Wait, what happened to our tape measure?
We are going out the pod door. I need to grab my keys.
We need to open the pod bay doors.
Oh, I get it. Open the pod bay doors.
So we need
That movie was too long.
I only had 2 of those, so what did you guys figure out to use? You guys said you were ready. There's meter sticks over there. There's
You gotta.
I mean, there's those yellow triangles, but I don't. Those are pretty thick. Yeah, but you need to be able to measure angle, like how high it lifts, right? But how can you tell where that goes to?
Onward.
Can you? I mean, whatever you guys think, but I have a feeling you might get a snag if all you take out is a protractor.
Check out my new
I mean, like,
video.
if you're just trying to be able to point up to an object, like, you could set this at your 0 degree, like, in the middle of your protractor and angle that. I mean, or a meter stick, or, like, even a ruler or whatever. But I just wish that some of the points. Not without me, just tell me to wait a second. You guys ready? I mean, you know, we're just going to be right out front of the school, so whatever else you grab, you can join us.
You could bring this and let's set it up.
Alright, go.
I feel like smacking someone.
interruption. Could I please have Mason Fields to the office? Mason?
have a big lead.
Oh, it's so warm.
Tom's pretty bad. I'm on the edge. Are you on lunch? The bird of losing it.
Mr. Marcy, can we go to lunch?
Chris first. Thanks, Jacob, because it would be totally fair.
Dude, I normally have to repeat myself a bunch for 7th graders. You guys are making me struggle this year. Normally my 8th grade class is easy. So, what struggles did we have?
Oh, I'm reading all of them.
None of them. Closing our giant. Someone's shutting your giant.
Closing your giant protractor, your clinometer, right? Adjusting your clinometer before you would actually take in the degree measure. So even if you have a tool, if you don't use it efficiently, it doesn't really help much. What else?
Finding the angle.
What do you mean finding the angle?
Being able to find it.
How so? Why was it a struggle?
It was super inaccurate.
How so?
Because we're using human eye.
Because we were judging it by eye.
Okay.
We had a
What
100-inch difference between 3 of ours.
what helped with being able to find the angle more accurately? Thomas?
Making sure to keep it still and like making sure to keep the point of the protractor at the bottom of the stick or whatever you're using.
Yeah.
And to make sure to keep the straight thing that you're using still and pointed at the top of whatever it is.
So, if you were going to design a clinometer, let's say money's no object. Well, it's kind of an object. You have a decent amount of money to do this. How would you invent a clinometer? Like, what would you do to make it better? If we said we were going to do this activity again,
Oh, make it so that you could
Hunter?
Like if you're using a construction, have like maybe like a laser pointer or something.
Yeah.
Ooh, laser pointer.
Yeah, that's
Jacob?
a good idea.
And like a protractor or something on it that tells you what the angle is.
Like to
Did you
have
know
it, like,
angle measure?
attached. To just have it like attached and then sticks.
Real clinometers. There's a variety of types, but this is one of the very
How does that
simple
work?
ones. Do you think I'm going to explain it
Oh,
since
yeah,
I'm
yeah,
showing it
yeah,
to you?
yeah.
So, you hold it,
Oh.
right? Not on the ground. You hold it. Then, I like these because they're weighted. You look through, so you would line up your eyesight through like a point here and a point here, and you get your straight line. As you turn your angle, this keeps pointed at the ground because it's weighted, but this is your 0 degrees. So as you angle up, and your little like wand part, whatever, comes back, then this is actually a brake. So when you squeeze it, it is loose, it turns, but as soon as you line it up, you let go with your hand, and then you can look at how many degrees you have.
That seems so helpful.
So one of the points of this activity was let's like practice some trig and try to do this. The other point was if you were one of these people way back when trying to invent how do we make better processes for things like I can't measure how tall that thing is. I can't measure how wide that valley is, but we're going to start designing a bridge for it. Right? You're not going to have somebody climb down all the way to the like other end with a tape measure.
I'll
right?
do that.
So we invent different tools and techniques to use the tools that will help us. So that's like a school version clinometer. They also have like fancy ones where it actually like there's a thing in it that moves and you can see the readout of it as you angle your head. Obviously, engineers and different people that like it matters more how particular they are. An old school compass, and I normally try to bring mine to school, but I forgot it. I'll bring it next week and show you guys. They actually have a little part of it. I wonder. So like these, and I have one that's kind of like this, actually more like that, where you can use like reflections and things like that to be able to measure the angles and line up your eyesight and actually kind of use the compass to help you out. But that is our little activity on clinometers and measuring angles. And have a great weekend, guys.
This is never going to be a height
Hey,
dictionary.
I have a sub on Monday in case I forgot to tell you guys I had basement work being done, so be cool for the sub. You guys will be doing closure. You'll be doing this chapter's closure.